The word problems we're going to start with are about working together. So let's take an example where we have two people, and it doesn't matter what it is. Let's say it's washing windows. June takes 4 hours, Sam takes 5 hours. And if we want to know how fast they are working together, your first thought is to add them. If we add them, 4 plus 5 is 9 hours. But wait a second, that actually doesn't make sense. It takes them longer to do it together, so we can't just add them. But the idea is correct. We just can't add the numbers as is. What we need to do is convert to kind of like a percent. So 4 hours, June can do 25% per hour. Sam can do 1 out of 5 or 20% each hour. And we're allowed to add the percents. So if you think about it, they can do 45% per hour. And it takes roughly a little over 2 hours, because 1 hour is 45, 2 hours is 90%, and the last 10% is a little past 2 hours. How can we find the exact number? Well, we just take this number, 1 divided by 45%. This is the same thing as 1 over 0.45, and if you plug it into your calculator, you'll get 2.2 hours. So basically what we're doing is, we're not going to use percents, we're going to use fractions, but we're adding the rate at which they can do per hour. We can add it up, and then dividing by 1, we can switch back to hours. So what we're actually going to do is use the 4 as is, 1 out of 4. June can do 1 part out of 4 in an hour. Sam can do 1 out of 5, and the answer we're looking for is the denominator on the equal side. So it's a rational equation. We have to get common denominators. So 4 and 5, nothing kind of is common with that. So I'm going to do 20 for my common denominator. So if I multiply the top and bottom by So I'm going to multiply the numerator by the same number so that I can get common denominators. So I end up with 5t. And here's where we've got common denominators, so I'm just going to get rid of them all, cancel them out. Now technically I am multiplying all the terms by 20t. And because they all cancel, I am just left with the numerators. Common or like terms, so 5t plus 4t, 20 over 9. Now, because it's a word problem, we don't actually use fractions. I want you to put this into your calculator and find out the actual answer with a decimal. And as we saw before, 2.2 hours rounded to 1 decimal place. So always use decimal for word problems. Leave it as fractions if it's just a math problem. There we go. We take all 3. We've got 2 people working together, so we divide by the time it takes each one. The unknown is on the denominator of the equal sign, and so we have to end up dividing to get the hours together. And that kind of makes sense. 4 and 5 hours, if you take the average of them, it's about 4.5, and this is roughly half of that because they're working twice as fast. And it will always be very close to the midpoint, but closer to the faster person. So here I have another problem. I've got Bill, who takes 6 hours, Sydney, who we don't know, and together they take 4 hours, which makes sense. Together they are faster than Bill by himself. Now, the basic idea is we're going to take the 2 individuals, add them together, and we will get the answer t together, how much time it takes together. But we actually know that. What we don't know is Sydney's time. So now that I've got it set up, I'm going to put the equal sign in there. These two added together equals 1 over 4. So I'm going to use common denominators. 6 and 4, I have to go up to 12. 6 times 2t times 12 times 3t. Remember, common denominator must have the t's. This already has it. These two don't. And I've skipped a step, but basically I'm going to end up with common denominators, and they all cancel because I multiply both sides by 12t. So 2t, I'm going to move this to the other side, and I get my time. T equals 12 hours. And T was Sydney, so Sydney is 12 hours long. Bill is 6 hours, Sydney 12 hours, together 4 hours, which we already knew. So it's basically the same thing. 1 over t plus 1 over t equals 1 over the answer. So read through this one in the notes, but the basic idea is Noah takes 9 hours longer. We're not actually given the time for Noah. We have no idea what Gustav is, but we're told 20 hours together. So how do we figure this one out? The easy one is 20. We're going to put this in the answer, 1 over 20. Now Gustav, we don't know it, so we have to come up with a letter. We can use X, we can use T, whatever we like, and we know that Noah is 9 hours longer. So we have to take the X and add 9 to it. So Gustav is 1 over X, Noah is 1 over X plus 9. This gets a lot more complicated because now we have a binomial denominator. We have a monomial and a number. So we have 3 different pieces. We need to get all 3 as the common denominator. So this one needs to be multiplied by 20, x plus 9. This one is missing 20x. And this one is missing x and x plus 9. So we have to do it to the top as well. So now I have to expand this. So I'm going to get 20x plus 180. This one I get 20x. And this one I'm going to expand x squared plus 9x. So from here, now I have to get everything together. I have an x squared, so I'm going to move everything over to this side. So I have equals 0. I have 20x plus 20x is 40x. And I'm going to subtract it from both sides. And I'm just going to move the equal sign over here so I have a lot more room. So 9 minus 40 is minus 31x. And the 180, I have to subtract it, equals 0. And you can move the equals 0 to this side. It probably makes more sense, but it really doesn't matter. So now we've got a trinomial. It's an easy trinomial. There's no number here. So I have to list the factor pairs of negative 180. And so list everything that multiplies to negative 180. And I've almost got it. I've got positive 31. I just switched the signs to get minus 31. And I put the equal 0 on this side. It really doesn't matter, but I like it on the right. Now I have my 2 solutions. And we've already gone over this. It's always going to switch. X plus 5 equals 0. Move the 5 over. Move the 36 over. There's my 2 solutions. It's always flipping the signs from the factors. There we go. Now, the one thing about this is, what is x? Well, if we go back to the beginning, x is Gustav's time, how long it takes him. I've got 2 answers. One is negative. Can he go backwards in time to paint the house? This one's not possible. So word problems, 95% of the time, 99% of the time, it's only positive answers. And in this case, Gustav takes 36 hours. If we want to find out Noah, we go back. Noah's x plus 9. So Noah would be 45 hours. So Gersab, Noah. So we have to go back to the question and see, are we answering it? This particular question, they asked for Gersab, so the answer would be 36 hours. So the next question for this type of problem, we've got Blair cleaning, and it takes 6 hours to clean the whole house. We've got Zoe, who's making a mess and making dirty walls. It takes her 9 hours to do the whole house. So the question is asking how long, if they're both doing it, will it take to clean the house? So we're going to start with the basic idea. We take the two people and we add them together, but we make them into fractions. So we're trying to find the together part, but here's the catch. Blair's going one way, he's cleaning it. Zoe's doing the opposite, she's making it dirty. So the one change we have to make to this is Zoe is subtracting. She's making it dirty, so she's going in the opposite direction. So now that we've got this, common denominators, so 6 and 9, the smallest LCD will be 18. And if we have common denominators, they'll all cancel when we multiply by 18t. So I end up with 3t. Oops. Subtract. So it takes 18 hours to clean the house if Zoe's making a mess.